Question 5b. The diagram below shows a sketch of the graph of y equals f of x, where f of x equals 1 over x squared for x greater than or equal to 0. Part 1. Copy or trace this diagram into your writing booklet. On the same set of axes, sketch the graph of the inverse function y equals f inverse of x. The graph of y equals f inverse of x is a reflection of the graph y equals f of x in the line y equals x. The idea is to swap the x and y coordinates around, including asymptotes, intercepts, and the domain and range. Here is the graph of y equals f of x, which is the original graph, shown in pencil. Here is the line y equals x, so that's the dotted line. Reflecting y equals f of x in the line y equals x will generate this curve in red, which is the graph of y equals f inverse of x. Notice that the y-intercept of y equals f of x is 1, which means that the x-intercept of y equals f inverse of x is 1. The graph of y equals f of x has the x-axis as a horizontal asymptote, and the graph of y equals f inverse of x has the y-axis as a vertical asymptote. Part 2. State the domain of f inverse of x. The range of y equals f of x becomes the domain of y equals f inverse of x, and vice versa. From the graph, we can see that the range of y equals f of x is y is greater than 0, since the x-axis is an asymptote, and less than or equal to 1, since that's the y-intercept of y equals f of x. Swapping the x and y around, we have the domain of y equals f inverse of x is greater than 0 and less than or equal to 1. Part 3. Find an expression for y equals f inverse of x in terms of x. Let the equation of the original function be y equals 1 over 1 plus x squared. The next step is to swap the x and y variables around. So x equals 1 over 1 plus y squared. The next step is to make the y variable the subject. So dividing both sides by x and multiplying both sides by 1 plus y squared, we have 1 plus y squared is equal to 1 over x. Subtracting 1 from both sides of the equation, we have y squared is equal to 1 over x minus 1. Combining both terms on the right-hand side into a single fraction, we have y squared is equal to 1 minus x over x, where x is greater than 0 and y is greater than or equal to 0. Taking the positive square root of both sides, we have y is equal to the square root of 1 minus x over x. Part 4. Let the graphs of y equals f of x and y equals f inverse of x meet at exactly one point, P. Let alpha be the x-coordinate of P. Explain why alpha is a root of the equation x cubed plus x minus 1 equals 0. The graphs of y equals f of x and y equals f inverse of x meet at point P, and point P also happens to be on the line y equals x. Find the x-coordinate of point P by solving simultaneously y equals x and y equals 1 over 1 plus x squared. So eliminating y, we have x equals 1 over 1 plus x squared. Multiplying both sides of the equation by the denominator 1 plus x squared, we get x cubed plus x equals 1. And subtracting 1 from both sides, we get x cubed plus x minus 1 equals 0, where the x-coordinate of P, alpha, is a root of x cubed plus x minus 1 equals 0.